Why do we need simulations? We already have plenty of data, you might argue. Why create even more artificially? This video introduces a new playlist focused on simulations. This is a joint project with our YouTube partner Julian. He is a statistician and uses the programming language R for his work. I'm a mathematician and follow the Pythonian path. Let's combine both. What can possibly go wrong? This introduction addresses the following questions. Don't we have enough data? Why are simulations useful and what will you learn? There is certainly plenty of data, so what is the point of simulated data? First, can we use the data? Nowadays, issues related to privacy and regulation might make it impossible to use certain data. Second, some data might be hard to analyze due to a lack of structure. Third, measurement errors can be substantial. For instance, do people always tell the truth? This is an example to illustrate this point. Based on survey data for the UK, it seems that calorie consumption on average has declined substantially in the last years. However, this is not matched by other data. For instance, obesity has been increasing over the same period. Maybe it is all water weight, or maybe someone isn't telling the truth. Finally, confounding effects matter. For instance, if you want to understand the impact of Brexit on UK exports, you need to deal with the impact of COVID on your time series. There are additional issues related to sampling, such as the self-selection bias. If you want to know more about sampling-related problems, please leave a comment below. Why are simulations useful? Sometimes it is impossible to collect data or conduct an experiment, for instance, in the case of rare events. In addition, certain variables cannot be observed, they are latent. This applies in decision making, as we only observe outcomes, but not the process of decision making. Simulations give us more control. We obtain clean data and can isolate the effects we want to study. In many applications, theory leads to a probabilistic understanding. Simulations are an essential part of various methods, such as bootstrapping or Markov chain Monte Carlo simulations in Bayesian analysis. What will you learn? We will explore applications in statistics, finance and physics. Finally, you will learn how to code simulations in various programming languages, including Python, R, Stata and OpenBugs, WinBugs. Moreover, we need to speed up our code using various methods.